Hello and welcome to KognitoKey. Today we're going to talk about something you use every single second of every day, but probably never think about. It's a tiny, tiny switch that literally powers our entire world. It's inside your phone, your computer, everything. So yeah, let's get right into it. So let me ask you this. What do you think is the single most important component inside your phone? I mean, we're talking about something that's repeated billions of times. Any guesses? Well, the answer is the transistor. And today, we're going to zoom in on one particular type, the real hero of our story, the NPN transistor. Seriously, you can think of this thing as the fundamental building block. It's like the single most important Lego brick in the entire set of modern technology. Okay, so what exactly is an NPN transistor? Well, the name itself gives us a clue. NPN stands for negative, positive, negative. And that's because it's basically a little sandwich. You have a thin slice of positive type semiconductor material squished between two negative type layers. All it really means is that the negative parts have a lot of extra electrons ready to move, and the positive part, well, it doesn't. And the entire magic of this little device is how it uses a tiny, tiny current to control a huge flow of those electrons. Now, to really get how this works, we gotta look under the hood, right? Let's take a look at its blueprint and break down the three essential parts that make this whole thing tick. All right, so here are the three parts, and each one has a very specific job. First up, you've got the emitter. It's highly doped, which is just a sciencey way of saying it's packed full of electrons, just waiting to be released. Then, in the middle, we have the base. This is our gatekeeper. It's super thin and only lightly doped, meaning it doesn't have many free electrons. And finally, there's the collector. It's the biggest part of the three, and its job is simple, to collect all the electrons that manage to get past the base. Now, here's something you might be wondering. Can you just swap the emitter and the collector? And the answer is a big no. They are not interchangeable. You see, the collector is physically much larger. And there's a really important reason for that. It has to handle way more power, which means it gets hotter. So making it bigger helps it dissipate all that extra heat. It's just a brilliant piece of engineering to stop our gadgets from melting. Okay, so we've called the base the gatekeeper, but how does it actually work? How does this tiny little region open the floodgates for this massive rush of electrons? Let's walk through it step by step. So it all starts when we apply some voltage, what engineers call a bias. Think of it like this. We set up one voltage that kind of pushes electrons from the emitter towards the base. And at the same time, we set up another, much stronger voltage that's pulling electrons toward the collector. Then comes the magic moment. We apply a very small current to the base. That's our signal. And that tiny signal is like turning a key. The gate flies open and a huge flood of electrons rushes out from the emitter. And because the base is so incredibly thin, they just zoom right past it and get swept up by that strong pull from the collector. So you've got this massive flood of electrons rushing through. You have to wonder, how many of them actually get stuck in the base, in the gatekeeper region? You'd be amazed. It's an incredibly small amount. We're talking only about 5%. And that right there, that's the whole point. It means that over 95% of the electrons that start at the emitter make it all the way to the collector. Think about that. A teeny tiny current in the base is controlling a massive current flowing through the main path. It's incredible. And this relationship is actually pretty simple to describe with an equation. The total current coming from the emitter is just the sum of the tiny base current plus the big collector current. See? Nothing gets lost. It's all accounted for. It's just being controlled and redirected. So this is the really cool part. What can you do with this amazing ability to control a huge current with a tiny one? Well, this gives the transistor two incredible superpowers. It can work as both an amplifier and a switch. Let's break that down. When it's an amplifier, that small input current at the base creates a much, much larger but perfectly proportional current at the collector. It's like taking a tiny whisper and turning it into a loud shout. That's how your speakers work. And as a switch, we can use that same tiny base current to turn the big collector current completely on, or completely off. And that simple idea of on and off, that, my friends, is the language of computers. It's the zeros and ones that power our entire digital world. And because it can do both of these things so well, the NPN transistor is, well, it's everywhere. It's in the amplifying circuits in your headphones. It's in the lightning-fast switching circuits inside your phone's processor. Its versatility is just astounding. All right, so we've covered a lot. What are the key things you should remember from all this? Let's do a quick recap. If you remember just one thing, let it be this. The NPN transistor is basically a tiny electrically controlled gate. A very small current opens the gate, which lets a very large current flow through. And this simple, elegant idea, amplification and switching, is what makes everything in our digital universe possible. Every single bit of data, every complex calculation, it all comes back to this one tiny, brilliant device. And that's a wrap on the amazing NPN transistor. Thank you so much for watching this explainer on KognitoKey. If you learned something new today, do me a favor and hit that like button, share this video with a friend, and of course, subscribe to the channel so you don't miss our next one. Thanks again and see you next time.